Welcome back. In this tutorial, we will simulate a three-phase, full-wave bridge rectifier in Simulink MATLAB. Problem statement. Simulate a three-phase, full-wave bridge diode rectifier circuit and make the following measurements. 1. Average DC load voltage. 2. Average load power. Getting started. So, let's get started. Launch Simulink and click Create Model to open a new blank model. Click the Save icon to save your model. Add the required blocks. Open the Simulink library browser, and then launch the standalone library browser. Now go to Specialized Power Systems. Double-click Power Electronics and add a diode block to the model. Go to Sources and add an AC voltage source to the model. Go to Passives and add a series RLC branch to the model. From Utilities, add ground to the model. From Sensors and Measurements, add a mean block and a multimeter to the model. Arrange the blocks for proper connections. Double-click the diode block, set the forward voltage to 0.7 volts. And uncheck the box to hide the measurement port. Rotate the diode block by pressing Ctrl+R on the keyboard. We'll need 6 diodes, so copy and paste the diode block 5 more times. Let's arrange the diode blocks properly. Select the AC voltage source, rotate it, and copy and paste it 2 more times. Let's rename the voltage sources. Open each voltage source and set the peak voltage to 311 volts. Set the frequency to 50 Hz. Set the phase angle of the second phase voltage to -120 degrees. Set the phase angle of the third phase voltage to 120 degrees. Connections. Let's make the connections. Open the RLC branch. Select R from the drop-down menu, and set the value of the load resistance to 10 ohms. For measurements, select branch voltage and current from the drop-down menu. Add a demux block from the library. Also, add a product block to the model. Open the multimeter block. We need to add the power GUI block before making the required settings in the multimeter. So, add the power GUI block. Next, open the Power GUI block, select Discrete as the simulation type, and decrease the sample time for better accuracy. Set the simulation stop time to 0.04 seconds. Open the multimeter. And select the RLC branch voltage and current. Connect the multimeter to the demux block. And connect the output of the demux block to the inputs of the product block. Copy and then paste the mean block. Let's add display blocks to our model. Open the mean block and set the frequency to 300 Hz. The load frequency is 6 times the source frequency. Since the source frequency is 50 Hz, the load frequency will be 300 Hz. Rename the display blocks. Finally, click Run to start the simulation. This is the value of the average load power. And this is the value of the DC load voltage. Let's verify the DC voltage value by comparing the obtained DC load voltage with the calculated value. Here's the calculated value. So, our result is close to the calculated value. You can replace the 3 independent voltage sources with a single 3-phase voltage source block. Let's remove these voltage sources and add a single 3-phase voltage source block. Connect the 3-phase source to the circuit. Open the 3-phase source block and enter the RMS value of the line-to-line voltage. Here's the formula to calculate the line-to-line voltage. Set the frequency to 50 Hz. Disable the internal impedance of the source. Let's run the simulation again. We obtained the same result. Summary. In this tutorial, we learned how to simulate a 3-phase, full-wave diode rectifier and obtain the average load power and average load voltage. Your task: repeat the same procedure for a 3-phase, half-wave diode rectifier. Thank you for joining us.